Hello everyone, our project is study and implementation of 3D printing technology using fused deposition modeling, and we are doing this with the guidance of Mr. S. Muthukumaraswamy, Assistant Professor, Department of Mechanical Engineering, Weldtech. And in the abstract, the 3D printing is a form of additive manufacturing technology where a three-dimensional object is created by laying down successive layers of a material. It is also known as rapid prototyping. It is a mechanized method where 3D objects are quickly made on a reasonably sized machine connected to a computer containing blueprints for the object. The 3D printing concept of the custom manufacturing is exciting to nearly everyone. This revolutionary method for creating 3D models with the use of inkjet technology saves time and cost by eliminating the need to design, print, and glue together separate model parts. Now we can create a complete model in a single process using a 3D printer. 3D printers are machines that produce physical 3D models from digital data by printing layer by layer. It is used in a variety of industries including jewelry, footwear, industrial designs, architecture, construction, automotive, aerospace, dental, etc. And then the introduction, guys. 3D printing is a form of additive manufacturing technology. It is a rapid prototyping process whereby a real object can be created from a 3D design. A 3D printer machine uses a SolidWorks model for rapid prototyping, and the design is stored in a STL format, and afterwards it is forwarded to the 3D printer. It can use a wide range of materials such as ABS, PLA, and composite as well. It is a rapid method and also it is cost optimized, from which it is used for rapid prototyping. Three-dimensional printing has the ability to impact the transmission of information in ways similar to the influence of such earlier technologies as photocopying. This identifies sources of information in 3D printing, its technology, required software and applications. This 3D printing influences many industries, as we have already told, such as automobiles, architecture, etc. And then, guys, the method which we are using here is additive manufacturing technology, which is AM, is an appropriate name to describe the technologies that build 3D objects by adding layer by layer of materials. Whether the material is plastic, metal, or concrete, it can be anything. The technology has especially been applied in conjunction with rapid prototyping. The construction of illustrative and functional prototypes, additive manufacturing is now being used increasingly in serious production. And there are different kinds of 3D printing methods, which are stereolithography, also known as SLA, digital light processing (DLP), fused deposition modeling, which we are using FDM, selective laser sintering (SLS), selective laser melting (SLM), electronic beam melting (EBM), laminated object manufacturing (LOM), binder jetting (BJ). And from all these we are using fused deposition modeling, which is FDM. And why we choose FDM? The reason is that we made a comparison chart between FDM, SLS and SLA, and from that we can see that the material used in FDM is thermoplastic, which is way cheaper than all those other things. Although the surface finish is good and the speed is is a bit average, and the cost is affordable, which is the main reason. The thickness of the layer is 0.1 mm to 0.4 mm. The size is compact. So we thought of using this FDM modeling process. Fused deposition modeling. The FDM technology works using a plastic filament or a metal wire which is unwound from a coil and supplying material to an extrusion nozzle which can turn the flow on and off. The nozzle is heated to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism, directly controlled by a computer-aided manufacturing software, which is CAM, and we learnt it. The object is produced by extruding melted material to form layers as the material hardens immediately after extrusion from the nozzle. This technology is most widely used with two plastic filaments, namely ABS and PLA, and the material which we use here is ABS, which is called as acrylonitrile butadiene styrene. FDM was invented by Scott Crump in the late 80s. Can the picture of our FDM model is shown below.
Working principle. In order to be able to print a physical object, that is an object in 3 dimensional, a 3D printer needs to be able to move on 3 coordinates, that is x, y and z. The mathematical generally have to the term of Cartesian coordinate system in order to specify the position of a given point in 3-dimensional space. A moving head printed the later sandpaper usually on one fixed axis from left to right and back, that is horizontal axis, while the needle moves draws wheels which advance the paper page on the other axis. The principles are same of the 3D printer except that it is able to move it on one more direction and thus is able to physically print the object. Nearly every 3D printer is built around the principle that its three principal axes are linear. This means their axes are right angle to each other and that they move in straight lines. Machines which use these principles are known as linear robots or Cartesian coordinate robots to delta or polar type robots. Typical example of linear robots are 3D printer but also computer numerical control machines. In order to move along these three axes, 3D printer generally makes use of fixed coding, timing belts and pulleys. In order to maneuver the print heads and or the print platform to the exact position needed. The support motor from an important part of any printer, as they are in the great part responsible for the quality of your print. That is, the cheap support motor is not able to realize the same accuracy as more expensive models. Also, when working, they tend to make quite some noise, and cheap support motors can be especially noisy. So this is the manufacturing process. So as you've seen, this is the this is the table which manufacturing of the products are shown, and it's a flow chart. And this is the frame of the 3D printer, and this is the lead screw and linear shaft and shaft holder. So size of the linear shaft is actually length is 350 mm and the diameter is 8 mm. Linear bearing which helps in moving of timing pulley, and pulley holder which helps in holding of the pulley. Timing belt helps to move the nozzles X, Y and Z. Timing pulley helps in moving of timing belt. Stepper motor, and it is a NEMA 17 motor actually, 3 to 6 watts, shaft diameter 5 meter, length 22 meter, torque 4.2 kilogram, step angle 1.8 degree, motor size 42 into 42 into 40 mm, and that's the motor holder. Extruder nozzle, this helps to allow the material to the nozzle. Heat bed helps to maintain the object in the bed. The temperature of the heat belt is 105 degree. Polymer material. So this is the material we are using in the 3D printer. SMPS. This is a switch mode power supply. This helps to regulate the input and output of the printer. Arduino Mega. This is used to control the stepper motor. And Arduino Uno, this is used to control the heat bed and the nozzle temperature. So this is the final picture of the 3D printer. In conclusion, this project works has provided us excellent opportunity and experience to use our limited knowledge. We gained a lot of practical knowledge regarding planning, purchasing, assembling and machining while doing this project work. Thus, we have developed and study and implementation of 3D printer technology using fused deposition modeling, which helps to know how to achieve low cost automation. The operation procedure of the system is very simple, so any person can operate by using more technique. They can modify and develop according to the applications.